Hello everyone, today we are going to solve DSA problem number 69 Sqrt of x, and this is a very easy problem of the DSA. So let's start from the description of the problem. So it states that given a non-negative integer x and we have to find the square root of that number x. Once you find the value, or you can say square root of a number x, we have to round it to the nearest integer. And one case is there. We all know that Python have a built-in exponent function or operator to solve the square root of x. But he states that we don't need to use any built-in exponent function or operator. So today I will tell you how to solve this problem without using any built-in function or operator. So let's start from the example first. So the first example is x is equal to 4. So the square root of 4 is 2. It's easy. Now comes to example number 2, and it shows x is equal to 8. So once we find the square root of 8, it will be 2.828. But according to question, we have to round it to nearest integer. So the answer will be 2. Okay. Now let's move to the coding part. Today I'm going to solve it in using Python. So first of all, we will write an edge case. If x is equal to 0 or x is equal to 1, then it means it will return the number itself. Why? Because we all know that square root of 0 and 1 is the number itself. Now let's move to the second point. We will take two variables, one is low and second is high, and we'll assign a value 1 to the low, and the number itself will be the value of my high. That's the main point. Now after that I will run one loop, that is while loop, and low is lesser than equal to high. Yeah, I already told you that I will tell you to solve this problem using binary search. So from here I am writing the binary search. Low is lesser than equal to high. Till that, second point of the binary search is to find the mid. So how will I find the mid? Low plus high minus low, and in Python for an integer division we have to use two forward slash and then two. So it will give me the mid. After getting the mid value, what I will do, I will square the mid. I will square the mid and I will store it into a one variable that is called a square. You can use it any other variable according to your preference or easiness. Mid into mid. So it will store the square will store the so that square variable will store the square of mid. So once I will find these two things, I will run three conditions. First is if my square value is equal to my given number x, it means I will return the value mid is my answer, is my square root of that given number. If it is not, if the if condition false, then I will check another condition. Maybe the square value is greater than the given number x. So if it is greater than the given number x, it means whatever the value present after the mid, that is also greater. So the square of those are also greater. So what I will do, I will move my high pointer to mid minus 1. Similarly, if that condition also false, then what the last condition is? The last condition is my square, the mid of the square value that is stored in a square variable. It it will be less than my number x. So it means whatever the value, whatever the elements present to the left hand side of the mid, which is also small. So the square of those elements will be also small. So what I will do, I will just move my low pointer to mid plus 1. Okay, once we come out from this loop, what I will return? I will just return my high pointer. Okay, because why? Because it's a floor. High pointer is my floor of Sqrt of x. I also wrote a comment. You can check this comment. So my high will be my floor of Sqrt of x. Okay, guys. So let's run the code and see what output will come. See, both cases are passed. Now let me submit the code. It is successfully submitted. Okay, guys. Just let me know if you have any question on that. And this only handles the integer value. If you want me to make a video on how to handle the floating point number, just let me know in my comments. I will upload the same as well. Thank you everyone. Just like, subscribe and share.